Okay, so we're going to do another chapter summary. This one is from Pure Year 2, Chapter 4. It's binomial expansion, but it's the Year 2 kind of stuff where the powers are no longer integers. They could be non-integer or they could be actually negative integers as well. I think Year 1, it's just positive integers that we have. So I'm going to do two simple examples and then a slightly more challenging one on the next page. There's not really a lot to explain for this topic. It's probably one of the most direct, sort of simplest kind of chapters. I've put this in a purple box. It's from the formula book that we've got here, and I'll be using that in both of these examples and the one on the next slide too. I just want you to take note though that you can only use this formula where there is a 1 in the first term of the bracket. So if we don't have a 1 in the first term of the bracket, we are going to need to manipulate it so that it does look like that. So for this first simple example that we've got here, we're going to find the first three terms in ascending powers of x, the binomial expansion of 2 over 3 plus x squared. State the values of x for which the expansion is valid. So to begin with, we want to write it so that it's written in this kind of form here. So kind of that standard power form, that standard index form that we've got. So I'm going to change this from being 2 over 3 plus x squared to 2 multiplied by 3 plus x to the power of minus 2. Now don't worry about that 2 that's outside the front, we can leave that there, but we are going to need to change this from a 3 to a 1. So I'm going to be dividing both of these things by a 3 and putting a 3 outside the bracket. Now when I put that 3 outside the bracket, it would be a 1 plus an x over 3. They've both been divided by 3. Now because there's a power of minus 2 here, that is actually going to apply to the 3 and to this bracket as well. So there's going to be a minus 2 here and a minus 2 here. So what I need to do for this first part is I'll multiply the 2 by the 3 to the power of minus 2. Well, 3 to the power of minus 2 is a ninth, and we're multiplying that by 2, so it's going to be 2 ninths. And now we can actually get on with doing the binomial expansion part, which is my 1 plus x over 3 to the power of minus 2. So I'll put this 2 ninths at the front, and now we'll get on with the expansion. When you do this expansion with the formula, you'll see the first thing we get is 1, then nx, and then I'll start talking about these parts in just a second. So we get a 1. Now n is the power, so I'm going to say that that is n, and the x in this case, the x part doesn't have to be exactly x. In our case, it's x over 3, so that is going to be n multiplied by x over 3. And then for our second one, we have n minus 1, and this is divided by 2 factorial multiplied by the x part squared. If we wanted to add in what the next part would be, I will do that for when we need it in the second example. So we're going to have, for the next part, there's going to be the n, which is minus 2. We're going to do n minus 1, which is minus 3. That is getting divided by, they've written it as 1 times 2. I just write that as a 2. And that's also going to get multiplied by the x part squared, which is the x over 3, all squared, and close off those big brackets. Now it's just a matter of being very careful with how we do this expansion and just simplifying each of these terms individually. So this one is very easy. It's just going to be a negative 2 over 3x. I tend to put the coefficient and then the x afterwards. And then for this, I don't tend to type anything in with positives or negatives on my calculator. I tend to decide whether it's positive or negative to begin with, and then just do all of the number calculations separately. So you can pretty clearly see this one is going to be a plus because we have a negative and a negative. So I'll just say that it's a plus. And then on my calculator, I'm going to be doing the 2 times the 3 divided by 3 squared, or multiplying it by a third squared, and also dividing it by a 2. You may spot that these 2's are going to cancel, but whatever way you want to do this. So I'm doing the 2 times the 3, I'm timesing it by a third squared, which actually I'm doing is a divide by 3 and a divide by 3, and I'm also dividing by this 2 here, and we get that it's a third. So I have plus a third x squared. Now my last thing I need to do is just multiply out by that 2 ninths, so I get the 2 ninths times by the 1. I'm then going to have the minus 4 over 27x, and then for my last part, I'm going to have the 2 over 27x squared. Now we do need to say what this is, the expansion is being valid for. If you look in this expansion, it is only valid when the modulus of x is less than 1. So we're talking about this thing. It goes inside the modulus and needs to be less than 1. We did our expansion at this particular stage here. So instead of it being an x, it's an x over 3. So it is valid for the modulus of x over 3 being less than 1. We can just multiply both of those sides by 3, so we just get that the modulus of x is less than 3. If you wanted to write that in a slightly different way, this is just saying that x has got to be in between 3 and minus 3. Either of those last two lines would be acceptable for this. So my second one is going to be with a fractional power. The first one was with a negative. This one is going to be with a fractional power. And we're also going to be finding the first 4 terms in ascending powers of x for this binomial expansion. And again, we're going to be doing a validity expression. So because it's a cube root, I'm going to write this as 8 minus 2x to the power of a third. We know that a third is for a cube root there. And again, we need there to be the 1. So I'm going to divide both of these parts by 8. When I divide them by 8, I would get a 1 minus x over 4. And that means we're going to have the 8 outside the front. And again, you've got to apply that third to both parts of the bracket that we have. So we're going to have the 8 to the power of a third. 8 to the power of a third is just the cube root of 8, which is just a 2. And then I have my 1 minus x over 4 to the power of a third. And I can now get on with doing the binomial expansion. So from the formula, it is, looking down here, it is 1 plus nx, and then I'll talk through these next 2 pieces in just a second. So it's going to be 1 plus n is my power, and x in this case is minus x over 4. And then the next one goes n. We then multiply it by n minus 1. A third minus 1 is minus 2/3. It gets divided by 2, and it also gets multiplied by the x part all squared. I'm just going to show you that from the formula. We said that we have the n minus 1, it gets divided by 2, and we get the x squared part. Now the part that's not in the formula, but you can kind of continue with the pattern, so for the cubic part, it would be an n minus 1, n minus 2 for the numerator. It gets divided by, instead of it 1 times 2, it would be 1 times 2 times 3. So it would be 1 times 2 times 3, which I'll probably just use as a 6. And then there's the x cubed. And you can predict what the next one would be for x to the power of 4. It would be n minus 1, n minus 2, n minus 3, divided by 4 factorial, which is 1 times 2 times 3 times 4. And then there'd be an x to the power of 4 at the end. So I'm probably not going to be able to fit this in on this line. Let's see if I can do, though. So it's going to be a plus. There's going to be an n minus 1. Now I'm going to minus 1 from that again, which is going to be minus 5 over 3. That's all getting divided by a 3 times 2. You can either write that as a 3 times 2 or a 6. And then we're getting it multiplied by our minus x. Oh, I'm never going to fit that in. Let's see if I can write it just a little bit smaller. Minus x over 4, all cubed. And I am going to have to drag this across, aren't I? Because I need to close off that bracket. So let's just move this and I'll write it out myself a little bit neater. So it's going to be minus x over 4 all cubed and close off that big bracket. So I'll leave the 2 and just sort out everything else that's inside. That is going to be, it's going to be a negative for the first part. It's going to be negative a 12th multiplied by x. Again, I'm just going to ignore whether it's positives or negatives in the calculator and just work them out before. So this is going to be a positive and there's a negative here. So it's going to be a negative. So on my calculator, I'm going to be doing a third, and I will times that by 2/3, divide it by 2, and then I can multiply it by 1 over 4 squared, or divide it by 4, whichever way you want to go about this. And we get minus 1 over 144x squared. And then for our last one, I'll check whether it's positive or negative. Well, this would make it positive. A negative being cubed is negative, so it's going to be a negative. And on my calculator, I'm going to do a third. I'll times that by 2/3, times it by 5/3, divide it by 3, then divide it by the 2, and also divide it by 4 cubed as well. And we get 5 over 5184 x cubed. So my last step is to multiply everything out. So it's going to be a 2 minus a 6x minus 1 over, what's that, 72 minus 1 over 72 x squared. And then I've got my 5 over 5184. Let's times that by 2. It's going to be minus 5 over 2592 x cubed for this. And again, we're going to have to do the validity part for this. So when we did the binomial expansion, we did it on this particular bit here. So it's going to be when the negative modulus of x over 4 is less than 1. Well, modulus sign means we can just ignore the negative. I can multiply both sides by 4. So I'm just saying that x has got to be less than 4. And if you wanted to write it in a different form, that is just saying that x is between 4 and minus 4 here. Okay, let's do a slightly more challenging example. I won't be referring to the formula in quite as much detail here, but we're going to use binomial expansions to show that this thing is approximately equal to this thing here. And interestingly, it does say binomial expansions, so we're going to need to think about how we can manipulate this. Well, if you look at our first part that we've got, which is our square root of 1 plus 2x over 4 minus x, that's the same thing as the square root of 1 plus 2x over the square root of 4 minus x. And if I was going to write that in sort of index form, it would be 1 plus 2x to the power of a half. And then the next part would be our 4 minus x, because it's in the denominator, it would be to the power of minus a half. So I'm actually going to work on these two bits separately. I'll do this red part and this purple part, and then I'm going to multiply them back together afterwards. So for the red part, I have my 1 plus 2x to the power of a half. It's already got the 1 at the beginning, so I can go straight in with the formula, and it's going to be 1 plus n multiplied by x plus n minus 1, that's minus a half, divided by 2 multiplied by the x part all squared. So it's going to be a 1 plus x. It is going to be a negative for this part. So I'm just going to do the quick bits of expansion. That's a half times by a half divided by 2 times it by a 2 squared. And we get minus a half x squared. Now, obviously, I'm going to stop at x squared because I'm only trying to show it up to the x squared part that we've got here. So I'll do the purple bit now, which is going to be my 4 minus x, what's that power? Minus a half to the power of minus a half. Now I am going to have to get that 4 out at the front, so there's going to be a 4 to the minus a half. If I divide both those bits by 4, I get 1 minus x over 4 to the minus a half. Now 4 to the power of a minus a half, that's the square root of 4 and the reciprocal, so it's going to be a half. And then for this part, I can just do my 1 plus nx, blah, blah, blah. So I have my 1 plus, my n is minus a half, my x is this, and then I'm going to do the n. I'll subtract 1 from minus a half, that's minus 3 over 2. I will divide that by 2, or 2 times 1, and then I have my minus x over 4, all squared, and close off those big brackets. So that is a 1. This is going to be a positive part, and a half times a quarter is an eighth, so it's 1 plus an eighth x. And then this is also going to be a positive because I've got two negatives that make a positive and a negative being squared that makes a positive. So on my calculator, I'm just going to do the half. I'll times that by the 3 over 2 and divide it by the 2. And I'll divide it by 4 squared as well. And I get 3 over 128 x squared. Last step is to multiply out by this a half so that I have a half plus a 16th x plus 3 over 256 x squared. So the thing that they want us actually to work out here is these two things multiplied by each other together, and I'm hopefully going to get this part that we have. So we can now go in and say that the square root of 1 plus 2x over 4 minus x is the same thing, oh, my alarm going off, the same thing as doing 1 plus x minus a half x squared multiplied by a half plus a 16th x plus 3 over 256 x squared. Now I'm only going to have to do, I should have used these approximately equal signs, I'm only going to have to do the expansion for the things that are going to give me something that's either a constant, an x, or an x squared. There's no point in doing it if it's going up to like beyond an x cubed or an x to the power of 4. It's just simply not going to be needed for this bit. So it's by myself, a little bit more space. Let's shift that up a little bit higher so I can hopefully squeeze in 2 lines here. So we're going to say we'll multiply everything to begin with by this 1 in this second bracket. So there'd be the half, there would be the 16th x, and there would be the 3 over 256 x squared. So I've done with that part. I'm now going to multiply everything in the second bracket by x. So I would have the half x, I would have the 16th x squared, but there's no point in multiplying the x with this last term because I get an x cubed, so it's not necessary to write down. And I'm going to multiply by this minus a half x squared. That only needs to be multiplied by this first one because the other two will give me powers that are too high. So I get a minus a half x squared times by a half is minus a quarter x squared. So my last stage is just to collect these like terms together. So I have the half for the first part. And then for the x terms, I have the 16th, I have the half, and that's just it for those two. So that's the 9 over 16x. And then for the x squared terms, I have the 3 over 256, the 1 over 16, and I'm going to subtract a quarter, and we get minus 45 over 256 x squared, which is exactly what we wanted it to be here, and that was all for part A of the question. Now we'll have a look at what's going on for part B. It says for part B, by substituting x equals 0.25, find an approximation for the square root of 10. Okay, well, I'll be subbing 0.25 into this in a second, but I need to find out what happens when you sub x equals 0.25 into the left-hand side. Well, when x is 0.25, we would have the square root of 1 plus 2 times by 0.25 divided by 4 minus 0.25. And we'll actually see what that gives us on the calculator. Now I'm just going to go straight in and type this. It is going to be the square root of 1 plus 2 times 0.25 divided by 4 minus 0.25, and it gives me the square root of 10 over 5. So this means when I substitute x equals 0.25 into here, it gives me the square root of 10 over 5. So I'm going to need to multiply my answer by 5 afterwards. So I'm going to do that. I'm going to say that I have a half, or let's just sub in a half plus 9 over 16 times by 0.25 minus 45 over 256 times by 0.25 squared. Let's see what that gives us. So I'll do my 0.25. So it's a half plus 9/16 of that minus 45 over 256 times by 0.25 squared. And we get 2579 over 4096. So this therefore means that the square root of 10 over 5 is 2579, or approximately equal to, I should use, is approximately equal to this over this, which means the square root of 10 is approximately equal to that thing times by 5, which is 12895 over 4096. And if we wanted to, we could give that to, let's just say, 3 significant figures, which is 3.15 to 3 significant figures. It might tell us in the question what we want it to be like. Now, just so you know, if I was actually just going to work out the square root of 10 on the calculator, the square root of 10 to 3 significant figures is 3.16. So it's a pretty good approximation. It is quite close to that one. Now, I didn't even do part B of the question. I've skipped a part. So this was actually part C of the question. I'm going to jump back up and do part B to state the values of x for which it is valid. So I'm sorry that I skipped that part out, but let's have a look at both of these parts. We did the expansion on this part and we did the expansion on this part. So for the beginning one, that is that the modulus of 2x is less than 1. In other words, the modulus of x dividing both sides by 2 is a half. And then the other one was minus x over 4 is less than 1. That's just going to be getting rid of the negative and timesing by 4, that x has got to be less than 4. So it is only going to be valid if both of these things are true. So it is only going to be valid if the modulus of x is less than a half, or we're just saying that x is between a half and minus a half, because obviously if you picked, say, the number 3, it would make this one true, but it wouldn't make this one true, and they both need to be true at the same time. So we take the one that has the smaller range for this part. And now we can answer part D of the question. It says a student attempts to substitute x equals 3 to find an approximation for the square root of 7. Comment on the suitability of this substitution. Well, let's just think what happens if we did put 3 into this part. If we did put 3, we would have had the square root of 1 plus 6 over 1. So it looks like it would give us the square root of 7. However, it's to do with it being valid or not. If we pick the value of x being equal to 3, it is outside of this range, so it will not give us it's not going to be a suitable substitution to use here. So I'm just going to explain that. I'm going to say, as the expansion is only valid for the modulus of x being less than a half, x equals 3 is not suitable as it is outside the range, as it is outside the range. The approximation will not be close. Now, if you want to, you could check this. You can substitute in x equals 3 into the right hand side of this part. You can calculate the square root of 7. You'll see they're nowhere close to each other at all. So really just checking about this validity range, and it's all to do with the fact that if it's outside of this range, these values get bigger and bigger, but actually we want these values to get smaller and smaller and smaller because we're only using 3 of them, and this is an infinite kind of series of things that we would have here. So that's everything on binomial expansions. A pretty straightforward topic, but one that's quite easy to slip up if you type something incorrectly in your calculator. Quickly wanted to mention that I am currently running the Bison Maths Award, which is an opportunity for 5 students who are studying for maths or further maths to be awarded with a cash sort of award of £150 and a graphics calculator as well. This is something I'm wanting to do to just kind of give back to the YouTube community. If you are watching this and the award is no longer running, hopefully it's something I'll be doing in the future. So do go on my channel page and see if it's currently running and something that you might be able to apply to. Anyway, guys, thank you so much, and I hope to see you in another video soon.